Hi everyone, this is week 3 of online learning. This is trigonometry lesson 3. I am going to call mine answer key. And this is using the primary trig ratios. And remember that the primary trig ratios are sine, cos, and tan. That's what that means. So we'll start with a warm-up. So far, we've learned how to name triangles. Fill in the appropriate name in the blank. Okay, across from the 90 degrees, that is always the hypotenuse. And remember, opposite and adjacent, those ones switch places depending on which angle you're talking about. Now, they have only labeled this angle, which means that that's the angle we're interested in. And so if we're talking about that angle, the one that is straight across from that angle is the opposite side, leaving this side to be the adjacent one means it's beside the angle alpha in question. So that's how we would label the sides of this triangle. And again, opposite and adjacent would switch places if we were talking about this angle up here instead. Okay, also we learned how to find a ratio given its angle or an angle given its ratio. So we're going to use a calculator to find the following. Let's get out the virtual TI. And again, I see degrees, so we have to make sure we're in degree mode. So let's go, nope, mode, good, degrees highlighted. And I am going to go sine 35, and I get 0.574, let's say, if we go to 3 decimal places. Cos 15 is 0.966. And tan of what angle is equal to 3.145? To get the angle, you have to go tan inverse of the ratio that's over here. So I'd have to go shift tan, 3.145, and I get an angle of about 72 degrees. So let's just write in there 72 degrees. Now let's solve for a missing angle or side in a triangle. See how I've got or angle in there again. To do this, there are 3 steps. So you label the triangle with opposite, adjacent, and hypotenuse. You determine the appropriate ratio to use based on that, whether it is sine, cos, or tan, and that comes from SOHCAHTOA, right? You use sine if you are dealing with the opposite and hypotenuse sides. You use cos if you're working with adjacent and hypotenuse, and you use tan if you're working with opposite and adjacent. And then you solve for a side or angle. Okay, so let's try a few examples. Example 1, solve for the missing side or angle, and we're going to use that procedure: label, ratio, and then solve. So if we have this angle 18 degrees, straight across from it is the opposite side, and we are trying to find that because it's x. Across from the 90 is the hypotenuse, and this other labeled side is adjacent. Okay, so we look at this, guys, and you go, I'm trying to find that opposite side, x, and I have the adjacent side, it's 15. So I just circled opposite and adjacent. And if we were to write down SOHCAHTOA again, we say which ratio deals with opposite and adjacent? The OA. Hey, that comes from tan. So it's the tan of angle 18 degrees is equal to the opposite side x divided by the adjacent side 15. So you set up your equation like that, and once you have that, you solve for x. Okay, so to get x by itself, it's being divided by 15 right now, so you multiply both sides by 15. We get 15 times tan, 18 degrees is equal to 15 divided by 15 is 1, just gives us x. So x is equal to 15 times tan 18, press equals, and we get 4.9, let's say. And that's how you do 1a. Okay, let's check out b. This is our angle in question. Right across from the angle is the opposite side. Across from the 90 is the hypotenuse, leaving this side, which is beside the angle, fancy word for beside is adjacent. Okay, and so then circle that we have the adjacent side, and we're looking for x, the hypotenuse. So which ratio deals with adjacent and hypotenuse? It would be cos. So you go cos of 56 degrees equals the adjacent is 3, the hypotenuse is x, and we solve this for x. Okay, and so this is one of those ones where the x and the cos 56 are going to just switch spots. But if you want me to show you again why that happens, what you have to do is you have to multiply both sides by x. First of all, that's to get rid of this dividing by x situation. And then you get x times cos 56 degrees equals 3. And to get x by itself now, you divide both sides by cos 56. Okay, so then you can end up seeing that x is equal to 3 over cos 56. So 3 divided by cos 56, bang, is 5.4. All right, on to page 2, everyone. Part C is still part of example 1, which is solve for the missing side or angle. This time we're looking for the angle. See how it's got alpha here? That's a missing angle. So let's label the triangle. This is millimeters, by the way. We're looking for angle alpha. Straight across from alpha is the opposite side. Across from the 90 degrees is the hypotenuse, which means this side over here is the adjacent. And we don't have that, so that's not going to come into play. SOHCAHTOA. Okay, so if we want to get angle alpha, we have the opposite side, and we have the hypotenuse. Which ratio deals with opposite and hypotenuse? OH. That comes from sine. So you go sine of alpha is equal to 11 divided by 12. And remember, when you have the ratio and you're looking for the angle, you have to go sine inverse of 11 over 12 to get the angle. So we're going to go shift sign, go 11 divided by 12, press equals, and we get about 66 degrees. Now let's try it with some easy word problems. When doing word problems, remember, draw a picture first, then label, ratio, solve. So the following diagram shows the difference between angle of elevation and angle of depression. So the angle of elevation, guys, is from your straight on line of sight up to something you're looking at. So this person is looking to the top of the building, and so the angle of elevation is how much you look up, basically. And the angle of depression is shown there in the diagram. It's the angle that goes down from your straight line of sight to look down at something on the ground. Okay, let's check out example 5. An observer standing 3.5 meters away from a flagpole measures an angle of elevation of 63 degrees to the top of the pole. Find the height of the flagpole. Okay, so we've got flagpole like this. The observer is 3.5 meters away. Okay, so an observer standing 3.5 meters away from a flagpole measures an angle of elevation of 63 degrees to the top of the pole. So the angle of elevation up to the top of the pole is 63 degrees. There's our 90-degree angle, and it says find the height of the flagpole. So we'll call the height of the flagpole right here h. Okay, and then we'll do our usual thing. Label the triangle, figure out the ratio we need, and then solve. Okay, so if we've got angle 63 degrees here, right across from the angle is the opposite side. Across from the 90 is the hypotenuse, which means this 3.5 must be the adjacent. So we have the adjacent, and we're looking for the hypotenuse. Which trig ratio deals with opposite and adjacent? There's opposite, there's adjacent, comes from tan. Okay, so we would say that tan of 63 degrees is equal to h over 3.5, and solve this simple equation for h. Okay, h is being divided by 3.5, so I am simply going to multiply both sides by 3.5. Cancels on this side. H is equal to 3.5 times tan of 63 degrees. Okay, about 6.9. 6.9, and that is going to be in meters, okay, because it gives us this measurement away from the flagpole in meters. Right, so there's example 5. Example 6 says a kite is flown with 210 meters of string. The angle of elevation of the kite is 61 degrees. How high is the kite? Okay, so a kite is flown like this. I am going to attempt to draw a kite like that. And a kite is flown with 210 meters of string, so this is 210 meters. The angle of elevation of the kite is 61 degrees. So looking up to the kite, we measure an angle of 61 degrees. Here is the assumed 90-degree angle that you need to be able to do SOHCAHTOA. And we want to know how high is the kite. So what is this h again? I'm going to write down SOHCAHTOA again. Now let's label the triangle. Across from the 61 degrees is the opposite side. Across from the 90 is the hypotenuse, leaving this side to be adjacent. And notice we want to find the hypotenuse, or sorry, we want to find the opposite side, which is h, and we have the hypotenuse. Opposite and hypotenuse. That comes from sine. Sine of 61 degrees is equal to, opposite is h, hypotenuse is 210 meters. And we have a simple trig equation to solve. Multiply both sides by 210. H is equal to 210 sine 61 degrees. Okay, and we get 183.7, I'm going to round that to, meters. And that is how high the kite is in the sky. And finally, example 7. Mr. Dewick is standing on an observation tower 30 meters above the ground and sees Ryan standing 120 meters away from the base of the tower. Find the angle of depression, Mr. Dewick, that should say. Has to aim his Nerf dart gun in order to hit Ryan. Okay, I am going to put Dewick in here. Okay, so let's draw a little picture of this. We have an observation tower. So Mr. Dewick is standing on an observation tower 30 meters above the ground. So this is 30 meters. And sees Ryan standing 120 meters away from the base of the tower. So the base of the tower, of course, is like the bottom right here, and Ryan is 120 meters away. And I'm just going to fix this line. Okay, so Ryan is here. Find the angle of depression. Mr. Dewick has to aim his Nerf gun in order to hit Ryan. Okay, so remember, Mr. Dewick's straight line of sight goes off like that, and the angle of depression from Mr. Dewick's straight line of sight down to Ryan is going to be this. So this is the angle we're interested in. Let's call it beta, maybe. And we're going to kind of have to hopscotch our way there, guys, because we have to work within the triangle first. And within the triangle, we can only get this angle here or this one. And so I'm going to get this one up closer to Mr. Dewick, because then we can easily get beta using some geometry. But let's figure out this angle right here, alpha. Okay, so we're looking for angle alpha first, and then we'll get angle beta. Okay, so to get alpha, we have to label the triangle. find the appropriate ratio, and then solve. So across from the angle is the opposite side. Across from the 90 is the hypotenuse, which means this 30 must be the adjacent. Okay, so we're going to get this angle, and we are going to use the opposite side and the adjacent. SOHCAHTOA. Okay, so which trig ratio deals with opposite and adjacent? Opposite, adjacent, that comes from tan. So I would say that tan of alpha is equal to opposite divided by adjacent. And remember, to get an angle, you have to do tan inverse of 120 divided by 30. Okay, so angle alpha is about 76 degrees. We round to the nearest degree for angles. And we will say, therefore, angle beta is equal to, here's how we're going to get angle beta. Notice, guys, that from Mr. Dewick's straight line of sight, that dotted line to the tower, that's a 90-degree angle. Okay, and so alpha plus beta equals 90 degrees. So beta is going to be 90 degrees minus the 76. And our angle beta that we're interested in, Mr. Dewick's angle of depression, is 14 degrees. Okay, so there's lesson 3, everybody. Here's the assignment. I would encourage you to try all of these questions. And notice at the end here, I think there is an answer key. Yes, there is an answer key. Okay, and I should be able to do a quick video showing some homework solutions by the end of next week. So there you go, guys. I will talk to you soon and send you another video shortly after this.